Right, we're going to be looking at matrix arithmetic. How do we add, subtract, multiply matrices? And when doing all of these arithmetic operations with matrices, well, it's going to be important to look at the order of the matrix, the dimensions of the matrix, how many rows or columns they have. Those will determine whether we can do some of our operations, and also excuse me, what the result of these operations will be. So first off, just know that for matrices, if in order for matrices to be equal, in order to have a matrix A equals a matrix B, the two matrices A and B must have the same order Remember, order is the dimensions of the matrix, so they have to be both the same order, and each corresponding entry must be equal. So the entry in row 1, column 1 has to be the same for the two matrices. Row 2, column 2 has to be the same, etc. Yeah, so, if I say that I have this matrix, 2x plus 4, y over 5 plus 6, 2, negative 1, is equal to negative 3, 5, 2, negative 1. I could ask you to solve for x and y. This is very simple. If for them to be equal, the corresponding entries have to be equal. So row 1, column 1 here has to equal row 1, column 1 here. So we can solve for x, subtract 4, gets us negative 7, divide by 2. So x is going to be minus 7 over 2. And then row 1, column 2 has to be equal to row 1, column 2. So y over 5 plus 6 must be equal to 5. So subtract 1, or subtract 6, I get negative 1. Multiply by 5, I get y equals negative 5. So that's a simple thing we can do with matrices being equal. For addition, the matrices again must have the same order. You can't take a 2 by 3 plus a 3 by 5 or anything like that. And I should say addition and subtraction. Addition and subtraction are the same operation, essentially, just in reverse. Addition and subtraction, the matrices must have the same order, and then you just add corresponding entries. Right. Yeah, so just a simple example. If we have 1, negative 2, 4, negative 1, 0, 3, plus negative 3, 3, 6, 4, 1, 2. We just take each entry and add them together. Row 1, column 1, I have 1 plus negative 3. So that's negative 2. In row 1, column 2, I have negative 2 plus 3, which is 1. Row 2, column 1, 4 plus 6, negative 1 plus 4, 0 plus 1, 3 plus 2. So I wind up getting the matrix negative 2, 1, 10, 3, 1, 5. Pretty simple. The second operation we're going to deal with is multiplication by a scalar. A scalar is just a number, not a matrix. So, for example, if I take 2 times negative 1, 3, 2, 4, negative 3, 6, how that works is that I multiply each entry by the scalar. I'm taking 2 times this matrix, I take each entry times 2, so that becomes -2, 4, -6, 6, 8, 12. Okay, so that's how scalar multiplication works. Then, we can do some slightly more complicated things with that. It's still not too difficult. If I tell you matrix A is -2, 0, 4, 1, 3, 7, and matrix B is 1, 6, -5, 3, 2, 4, and I say solve for matrix X if 3x plus 2a equals b. Well, I can go ahead and do my matrix addition, subtraction, and also multiplying by a scalar to work this out. So just doing a little bit of simple algebra, I would get 3x equals b minus 2a, and that gives us that x then equals b minus 2a over 3. Now dividing by 3 is the same as multiplying by 1/3, so I can say it's 1/3 times b minus 2a. So then x is going to be 1/3 times, well, matrix B is 1, 6, -5, 3, 2, 4, minus 2 times a, means I just multiply every entry of a by 2, so that's -4, 0, 8, 2, 6, 14. And then I subtract those two matrices. I don't need the parentheses anymore. So 1 minus -4 is 5, 6 minus 0, -5 minus 8, minus 13, 3 minus 2 is 1, 2 minus 6, -4, 4 minus 14, -10. And then x is 1/3 times that, so that's going to be 5 over 3, 2, minus 13 over 3, 1 over 3, minus 4 over 3, and minus 10 over 3. So we can do simple matrix equations using those operations. Right, so that's scalar multiplication and kind of putting together addition with scalar multiplication. Final note, if I say something like this, evaluate 1, -2, 3, 4, plus 3, 0, 2, -4, 1, 5. Well, these two don't have the same order, so they can't be added together. The dimensions don't match. So you can say either this, you can just say this is not possible, or you can say that the result does not exist. Either way, whichever of those is fine, and that's just your answer. Yeah, because we can only add matrices if they have the same order.